Murray's Law explained, tree branch heat sink design. Murray's Law explains how parent and child channel diameters relate to reduce energy loss during fluid flow. It is a key principle in natural branching. Fluid flow branching. Visualize fluid flowing through a large channel that symmetrically branches into smaller ones, showing efficient flow distribution according to Murray's Law. Murray's Law equation. D0 cubed equals D1 cubed plus D2 cubed governs parent and child channel diameters to optimize fluid flow and minimize energy loss. Symmetric branching. Parent channel splits into equal child branches for energy-efficient flow and balanced sizes. Asymmetric branching. Unequal child branch sizes optimize flow differently, maintaining low pressure loss and efficient cooling. Heat sink design steps. Choose main channel diameter. Split into 2 branches. Apply Murray's Law equation. 1. Step-by-step heat sink design. Channels decrease diameter from trunk to branches, visualizing smooth fluid flow and gradual branching. Callouts: energy-efficient flow, natural fractal design, optimized channel diameters. Benefits of Murray's Law: improved flow distribution, reduced pressure drop, and enhanced cooling performance in heat sinks. Biomimetic heat sink 3-dimensional view. Murray's Law for smarter cooling design.